Good evening, everyone. This is Zhang for CS6263 Spring 2019 paper presentation. Today I'm going to present the paper, A Large-Scale Empirical Analysis of Chinese Web Passwords. So this work is by three authors: Zhigong Li from Fudan University, Wei Lihan from Fudan University, and Wen Yuanxu from Zhejiang University. It's printed on the 23rd Unix Security Symposium, San Diego, California, on August 22, 2014. It's the links for the paper you can download from the website directly. The contents of the presentation includes motivation and introduction, data setup, password comparison, resistance to guessing, cross-region guessing, and a short summary. Motivation and introduction. Passwords are the most widely used credentials for authenticating web users around the world, including the users that do not speak English. Later work has studied the impact of regional conversion and languages on password selection, utilizing a large dataset of passwords. To understand the difference between Chinese and English passwords, this paper leveraged over 100 million leaked and public available passwords. Data setup. Here we have over 100 million passwords from several popular Chinese websites, such as CSDN, Tianya, Dudu 7K7K, 178.com, and two English websites, RockYou and Yahoo. From this table 1, we can see there are about originally 114 million passwords. After removing the duplicates, the remaining is 105 million passwords. For the Chinese websites, the Tianya website has about 13 million passwords, and the English website RockYou has 32 million passwords. So the data set is huge, and both English and Chinese have huge passwords leaked. The first comparison is the most popular passwords. The 5 most popular passwords constitute 4.14% of all Chinese passwords and 1.69% of all English passwords. So from this table 2, we can see the top 5 Chinese passwords are all digits only. And for English, the top 3 are digits only, and they share some common passwords, like the first one, 1, 2, 3, 4, 5, 6. And also the second one, 1, 2, 3, 4, 5, 6, 7, 8. You can see both Chinese and English users use some very simple passwords. The second comparison is the character distribution. So passwords can include digits, letters, and symbols. So for this table, the red circle represents English passwords frequency by character, and this rectangle is for Chinese passwords frequency per character. For the first few, they are digits. You can see both Chinese and English passwords have a lot of digits, and Chinese use more frequently digits than English users. And for the letters from here to here, most Chinese passwords use letters less frequently than English passwords. And some letters exhibit similar usage percentage for both groups of passwords. From here to the end of the chart, they are all symbols. So both Chinese and English passwords use less symbols. And in general, English users use more symbols in their passwords than Chinese users. The next metric is the compositions and the structure of passwords. From this table, we can see around 50 of Chinese users prefer digit-only passwords. So the passwords can be divided into small subcategories by their compositions, like digits only, letter plus digit, letter plus symbol, symbol plus digit, and letter plus digit plus symbol. So in the first column of this table, we can see Chinese web passwords have roughly 30 or 50% of digits-only passwords, while for English passwords, they're only about that's 15%. On the other hand, for letter-only passwords, for English web passwords, they have about 40%, but for Chinese, they only about 11, 20, 12%. If we count for letter plus digit only passwords, then we'll see roughly Chinese and English both have a large portion of passwords, so no obvious differences among them. And for all the most popular structure, for Chinese, of course, they are all digits. We have 8 digits, we have 6 digits, and for English web passwords, they are all 6-digit letters. The author can also compare the keyboard patterns. In order to input the keyboard password, we need a keyboard. So we have 3 patterns for the keyboard. The first one is the same row, which means the same row passwords are formed by a consecutive sequence of characters in the same row on keyboard. The second pattern is zigzag. The zigzag passwords are formed by a sequence of the characters where each key is adjacent to the next one, but not in the same row. The third one is the snake pattern. The snake passwords consisted of a sequence of characters whose keys are adjacent on keyboards. So, for both Chinese and English passwords, they are this 3 pattern. The meaning is from the same row. So, which means users prefer to input passwords from the same keyboard row because it's easy to remember, I think. This comparison is for Chinese pinyin and English words. Chinese pinyin is designed to represent the pronunciation of Chinese characteristics. Pinyin are widely used in passwords of Chinese users. So out of the letter-only passwords, pinyin are the dominant patterns for Chinese users in composing their passwords, and the English words dominate the English passwords, of course. If you check the letter-only passwords, for Chinese webs, passwords around 40%, 50% of Chinese pinyin, and only 15% are English words. On the other hand, if for the English passwords, only 4 or 6% of Chinese pinyin and around 30% of English words. So this part, for the Rocky Yahoo, they have also some small portion of pinyin in their password, which means highly suggested these users are also from China. So the most passwords have the similar pattern. Still Chinese pinyin is used by a lot of Chinese passwords, and English words are used by English passwords. Another interesting thing, if we count the top Chinese pinyin and top English words, then we found the love is always the main theme of a human being for Chinese and English passwords. For English, the I love you, the second one and the third one love, the top English words. While for Chinese, the first one 我爱你 is the same meaning as love or I love you. And also, the names of pinyin are widely used in Chinese passwords, like this last name Li, last name Wang, and last name Zhang. This is also my last name. Next one, and the dates format. 6 digits dates such as YYMDD, MMDDYY, and DDMYY, and 8 digits dates such as YYYYMMDD, MMDDYYY, DDMMYYY are analyzed. So from this table, we can see for most Chinese websites, they prefer the YYYY MMDD format. Because Chinese prefer use, by Chinese traditional, we always start with year, the months, then dates. Well, for English users, they prefer to put the YYYY at the end of the dates, because in English, they usually write the year at the end. A similar pattern also holds for the 6-digit format. We have YY, MMDD, so also Chinese prefer use the year and the beginning. And for English users, they prefer use Y1, the year, at the end for MMDDYY and the DDMMYY. Also for dates, the order compare the composition and precision. So for both Chinese and English users, they prefer to have dates appear at the end of passwords and rarely place them in the middle. As this table shows, both English users and Chinese users, they usually put the dates at the end. Some of them put it at the beginning, but only few put them in the middle. I think because for the end, usually I input some, like for me, I input some letters in the beginning. Then I found, okay, there's, which I can remember easily, but then I remember I still need some digits. Because some passwords need at least 8 digits or even 12 digits, so I put some dates there. So that's why as English and Chinese users prefer to put the dates at the end. After the huge amount unpacker analysis of the Chinese and English passwords, the author began to test their resistance. So measure password sets. So password resistance are measured by some standard metrics. They are like the expected number of sequential guesses to find the password of account if the attacker proceeds in optimal order. The expected number of guesses need to succeed of a probability alpha. Also, the probability that an attacker can correctly guess the password of an account by giving beta guesses. And also the alpha guesswork expected number of guesses per account to achieve a success rate alpha. So we have guesswork, we have alpha work factor, beta success rate, and alpha guesswork. So the author in this experiment assumed attackers know the exact distribution of the target passwords set and calculate the password strengths. So this is called intra-set guessing. A small portion of Chinese passwords are repeated and weak, but guessing a majority of the Chinese passwords is hard as guessing English ones. So from this screen, we can see that for the G, H infinity, and G alpha, G H infinity, the larger value means a strong security. And for the gamma, so a smaller value indicates a strong password. So you can see for most Chinese and English passwords, they have a very large G value. And also for the gamma, the ISO value is small. So which means on average, all these passwords are strong passwords. At least most of them. So although part of Chinese users use weak passwords that are easy to guess, a considerable number of users still carefully select passwords to protect their accounts. So this curve shows the success rate per alpha work factor. So as the cracking success rate increases, we need more power or work factor to crack the passwords. So as you can see, as the alpha increases, the curve increases dramatically. It means if the attacker wants to increase high attack rates, cracking rates, then they need to put a lot of effort to guess the passwords. For this 7 websites, especially this one, the Dudu, it has a very higher curve comparing to most larger curve compared to most websites. The reason is that this Dudu website is a commercial website which includes money transaction. So for Chinese users, or for most users, if they have a website which includes money transaction, they will by default or implicitly use some stronger passwords than other websites. You can see other websites like CSDN, it's a technology share website. Tianya is like BBS. So they don't include money transaction or sensitive information. So users do not know who you are on the websites. So they only choose some weaker passwords. The author did another experiment. So attacker can get passwords from website when he only processes a password set of another website, and this is called cross-set password guessing. So two metrics, alpha work factors and beta success rate, are used to evaluate the resistance of cross-set guessing. For the same alpha value, the alpha work factors of cross-set guessing is larger. So you can see this picture. So alpha work factors of cross-set guessing. So if we see x larger than 1, it means the x optimal order. We use the x optimal order to guess y's passwords. For example, the CSDN larger than rock2u, it means using the CSDN optimal order to guess rock2u's passwords. So if you check this website comparing to this chart, comparing to this chart, for the same success rate, the alpha work factor increase a lot for the cross-set guessing. So this means cross-set guessing is harder than the in-site guessing. Also, these two scenarios are examined. So giving the passwords from the 5 Chinese websites and the prior knowledge, how well can we guess the passwords for rock2u? And giving the passwords of rock2u, how well can we guess the passwords of the 5 Chinese websites? So comparing to this gamma, remember this gamma, smaller value means the password is hard to crack. So comparing this smaller value of gamma to this interset gamma value. S gamma is about 10^8 scale, but this gamma is cross-set cracking is only about 2-3%. So it means the low beta success rate means the cross-set guessing is harder than the intra-set guessing. The last part is called guessing with probabilistic context-free grammar. So the PCFG-based guessing method increases the efficiency of password cracking. So key of PCFG is to generate password rules or structures, which means some passwords, instead of using other websites or current websites passwords, we use some rule to generate some passwords to guess website passwords. So the rules can be constructed either from passwords or word marking templates that can be filled in with dictionary words. So for password training sets, Rocket UTS, Rocket Doodle TS, Rocket UTS, and Doodle TS, and the two dictionary of opinions, E-edit and C-edit are constructed. So we use the passwords from these dictionaries to guess the passwords in these training sets. Let's see the result. The first 4 bars, you can see after adding the date to the dictionary, the percentage of correct passwords increased greatly. It's a similar pattern for other websites, other training sites like Rocket UTS. They also have a similar pattern. After we add dates to the dictionary, then we can have a higher correct passwords percentage. Okay, let me summarize the presentation. This is the paper. It's the first large-scale empirical study on Chinese web passwords. So the Chinese user prefer digits in their passwords than English users. Pinyin and dates also appear often in their passwords. For English users, English words appear the most. So website passwords creation policy nowadays is very complex, and the semantic meaning of the Chinese words also maybe play some role in the passwords. So all this can be further investigated. Thank you. This is my presentation.